change from a graph. Are you ready? Oh, I'm on page 238. All right, so this table represents play attendance, okay? I want you to take a look at this. So every Saturday for 10 weeks straight, a community play theater put on the same play every Saturday for 10 weeks straight, okay? Your x-axis is the week of performance, and your y is your attendance. So I want you to kind of look at what these things mean. So on week 1, we had 124 people show up, okay? Now, here's the deal. I want you to look at this distance. Shh. So this is, I don't know, it's about a centimeter. So on my paper, I'm using a centimeter to represent 100 different intervals. You can't get that right and guess exactly. When these numbers are kind of like, you got to take a guess, most of the time, they're going to give you the ordered pair, okay? So on week 1, there were 124 people. By week 4, 232 people came to see this play. What do you think happens? I mean, there's all kinds of variables. Week 1, maybe somebody saw it, they said it was good. The more people per week started to come. And then on week 4, it reached its peak performance. What happened after that? Yeah, maybe it's a small town. Maybe everybody in the town saw the play, and the attendance started to decrease. And finally, by week 10, only 72 people came because half the town already saw it. Most of the town already saw it, right? So what we're going to do is I'm going to ask you some different questions about this. And I'm going to say, from week 1 to week 4, what was the average increase or decrease in attendance per week? Got it? This is what I need you guys to understand. The PSAT is not going to say, what's the rate of change from this week to this? It's going to say all these fancy words that make you think something hard. From weeks 1 to week 4, what was the average increase per weekly attendance? It's the rate of change. Now, I'm going to show you something. So they actually gave me 2 points, 1,124, 4,232. Now watch. How many of you kind of didn't really like this? 1,124 to 4,232. Okay, how many of you kind of thought that this formula that we did yesterday was a little annoying? 4,232. Basically what you're saying is from week 4 to this week, so 232 minus 124, and then the change in the weeks was from week 4 to week 1, so it was a difference of 108 people over the course of 3 weeks, means that attendance increased by an average of 36 people a week, right? 36 more people, 36 more people, 36 more people. Got it? If that is annoying to you, I want to point something out. How many of you kind of liked doing it this way from a table? I kind of like that too. I kind of think that this is a little easier to do than this whole crazy formula. So watch. If X is my number of weeks and Y is my number of people, on week 1, 124 people went. On week 4, 232 people went. Are you still kind of doing the same thing? Yes. So from week 1 to week 4, it went up 3. From week 1 to week 4, it went up 108. And that's okay as long as you remember when you divide that you do the Y divided by the change in X. And you're going to get 36. It's just a matter of preference. That, I have a lot of kids make mistakes with this formula. So if you never want to use that formula again, could you maybe just put it into a table and do it that way? Sure. So that's going to be totally up to you. Okay, let's take a look then at maybe so from week 4 to week 6, the attendance started to decline. If I were to ask you the same thing. So from week 4 to week 6, what was the average weekly increase or decrease? Would you know what to do? Yes. You would take those 2 points and either subtract them with the formula or take those 2 points and put them in a table. Okay? Let me just show you that real quick. So from week 4, we had the 4,232. And we had the 6, what is it, 204? 204. And you have the stack and subtract options too. You can stack them and do the whole, right? Remember that? 6 comma 204. Remember that? So you could say, well, I'm just going to subtract these two and put it here, and then I'm going to subtract these two and put them here, okay? So now let's take a look at this. If I wanted to do it this way, week 4 had 232 people. Week 6 had 204 people. So now what am I doing? I'm finding that from week 4, as the number of weeks went up, this time the attendance actually did what? It went down. It went down by 28. Don't forget to put that little negative. That's important. So now my change in my attendance is decreasing, but my number of weeks increased. Obviously, I can't go backwards. So what does negative 14 mean to me? That from week 4 to week 6, an average of 14 people per week less went to see that play. Do you understand? Okay? So if I were to show you a graph like this, I mean, could you do the same thing? If I showed you this and said that here's the sales. So this is day 1 of the sale, and this is the computer games that were sold. Again, notice that that's a really big interval. They have got to give you ordered pairs, right? Okay? So on day 1 of the sale, they sold 45 computers. By week 4, news got out that these computers are on sale. You better go to Best Buy and get them. So by week 4, 114 computers. Are you getting it? So you would take any of these 2 pairs that you want. Use the smaller ones. You can either do the formula or put them in a table. Okay. I do want to point out one thing, though, for something like this. What if the I'm actually going to just show you what your practice test looks like. What if they gave you a table or a graph like this? What's missing from the graph? Either a line or the actual ordered pairs, right? So it doesn't say, oh, the name of this ordered pair is this, comma this. Why doesn't it? Because you don't need it. It's right there. Very obviously seen is the fact that week 1 cost that much. Week 3 cost this much, and so on. So how would you find the rate of change for this? The same way you would find it for the others. You would just pick any 2 points you want. So you have to be able to look at this and say, oh, I'm going to choose point 1, comma, 3180. Then I'm going to choose, make it interesting. Let's choose point 5, comma, 3900. I'm doing this to show you that it doesn't matter what 2 points you choose. Any 2 will do it. And then if you want to put it into a table, do it from there. Got it? Okay, and then the last thing I'm going to remind you of before we're done is this. And this is what we did before we went to break. Remember that little machine I hooked you guys up to and had you walk the path and do this? This is, I don't really care about numbers. This is just somebody who it says a student commutes from home to school by walking and riding a bus. Describe the commute in words. So if this is time, what's happening right here? What do you think, Ash?
The students walking.
Where?
To the bus stop.
Yes. They're not walking to school right here, are they? They're walking to the bus stop. Okay? What's happening here? They're waiting for the bus stop. And what happens here? They get on the bus. Now watch. Now, a lot of people said they speed up. Well, in a way they do, but notice that the y-axis isn't speed, it's distance. But how do you know they're speeding up? Because their distance from their home is decreasing faster than it was. Okay? Then I can maybe ask you specific questions like, how long was she waiting at the bus stop before the bus came? How long was she waiting I don't need numbers to figure this out on the graph. 2 2 2/3. She was waiting for 2.5 minutes. How long did it take her to get to the bus stop? 4 minutes, right? Now, Do you, for this graph, need to do a full-on 0, 0, 1, comma 4, put it in the table, do all the subtracting? No. We're getting to the point where you should be able to maybe start to figure out that rate of change. And guess what? This is going to like blow your mind. Slope is defined as rise over run, right? So for 1/4, the slope of that line is 1/4. So 3 different ways to find rate of change from words, from a table, and from a graph. Do you understand how to find rate of change for all 3 of those? Hopefully, yes. Tomorrow we practice, okay?